Welcome to chemical bonding. Okay. Chemical bonds. A chemical bond is a result from attraction of the nuclei for electrons. All atoms are trying to achieve a stable octet. This is the key to bonding right here. Okay. That the attractive force of the nucleus is stronger than the repulsion of two electrons trying to get together. Okay. So in other words, the protons in the nucleus are attracted to the electrons of another atom, and that's where electronegativity comes into play. Okay, so here's a little joke for you. What did the atom of fluorine say to the atom of sodium? You complete me. Here's why. There are two major types of bonding, and we already kind of talked about them when we were naming our um, our compounds and our molecules. Ionic bonds form ionic compounds and they transfer of electrons. So ionic bonds transfer, covalent bonds form molecules, and I would know these two things here too, and they share electrons. And we're going to look at all aspects of this, okay? Now those are the two major types of bonding. Now one type that's not too major, but we do talk about it a little bit, is called metallic bonding. And metallic bonding occurs between like atoms of a metal in a free state, and the valence electrons are mobile. We call them a sea of electrons, okay? Positive ions in a sea of electrons, and some metallic characteristics are right here. So I think there's one more. Okay, so they have high melting points, ductile, malleable, and shiny. This is why they have all of those properties, is because of the sea of electrons. They're harder substance. They're good conductors of heat and electricity. So I'd do that one here. As a solid and a liquid. Okay. Here's kind of what it looks like when there are mobile electrons or a sea of electrons. Do you see all these electrons out here? They're just kind of flowing like a sea of electrons. And so when you pound on them to flatten them out, they just kind of spread. Okay. And so they can flatten. All right. Let's get into the ionic bonding. Why did we crisscross? Why were we even worried about crisscrossing the charges? Well, because ionic bonds, of course, have ions in them, and they are transferring electrons between valence shells of the atom. So ionic compounds are made of ions. They are not molecules. Okay, they're made of ions. Ionic compounds are called salts or crystals. Now this is going to come in handy when we get into acid-base reactions, so kind of keep that in mind, that ionic compounds are called salts. They always form between metals and nonmetals, okay? And that's why, because metals are positive and nonmetals are negative. There's your cations and your anions. And the metals lost an electron, the nonmetals gain electrons. Okay. Ionic bonds can also have an electronegativity difference of greater than 2. They can also be a little bit less than that. We're going to say greater than 1.7. Okay. You look up the electronegativity of atoms in the bond and subtract, and I will give you a chart for that. So another ionic bond is any compound, with a polyatomic ion. And of course, there's your ions right there, okay? So like NaNO3. That's why we leave everything alone when we write formulas and name. Ionic bonds is a transfer of electrons, and this is an example of what's happening. So sodium is giving their one electron away, and if you notice, it's becoming very stable in an octet right here, whereas this chlorine, before it picks up the electron, only had 7, now it has 8. Okay, so now this one has 8, and this one has 8 in its outer shell. So properties of ionic compounds. They're hard solids at 22 degrees Celsius. They have high melting temperatures, melting points. They are non-conductors of electricity in solids. However, when they are dissolved in liquids, they are very good conductors of electricity. Okay, so make sure you write these properties down. They also have, they also dissolve in water. And there's one other thing, high boiling points. They also have high boiling points. Okay. All right. Covalent bonding. They are pairs of electrons that are shared, and they are between nonmetals. That is why we have prefixes. Okay, so these were the ones that had prefixes. And the ionic bonds were the ones that crisscrossed. Okay, but this is the reason why, because they have a pair of electrons that are being shared in their bonds. Electronegativity difference is less than 2.0, or in our case, we're going to be less than 1.7. Okay, they form polyatomic ions sometimes. Okay, and let me go back. Okay, so properties of molecular substances. They have low melting points and low boiling points. They're relatively soft solids as compared to ionic compounds. They're non-conductors, or they do not conduct electricity in any phase. Okay. And we also call that they are compounds, but they also can be called molecules. Okay. All right. We're going to skip this one real quick. Okay. Drawing ionic compounds using Lewis dot structures. Okay, so Lewis dot structures basically means this. I don't know if we've talked about it, but I'm going to put the video out there. But Lewis dot structures can only have 8 dots, and they are the valence electrons only. Okay, so if you look here, these are all of our valence electrons for those columns that we've covered. Symbols represents the kernel of the atom, the nucleus or inner electrons, and the dots represent the valence electrons. So you can only have a total of 8 dots, and I'll probably go over that in class. So how do we get here? This is the finished Lewis dot structure for NaCl. Okay, sodium had 1 valence electron. Chlorine had 7 valence electrons. Okay, 2, 4, 6, 7, and 1. What we're going to do is we're going to transfer this electron right here. So chlorine is now going to have this extra electron, and sodium still has those inner electrons, but we don't show them because they're inner electrons. But because it gave away the 1, that's why it became positive, and that's why this one became negative, because it picked up an extra electron. And we have brackets around it to show that they are ionic compounds bonded together. Okay. So step 1, after checking that it is an ionic compound, determine which atom will be the positive ion and which one will be the negative ion. Step 2 is write the symbol for the positive ion first. Always positive, then negative. No dots. Draw the electrons dot diagram for the ion, the negative ion, and complete the outer shell. And make sure you put it in brackets and show each charge. Okay, so I want you to try drawing these 4 compounds as Lewis dot diagrams. We will go over them in class, okay? All right, drawing molecules using Lewis dot structures. This is a little bit challenging. Again, they're going to be the inner, use symbols represents the inner nucleus, the dots represent the valence electrons. However, here's where it gets a little bit different. Always remember, atoms are trying to complete their outer shell and get 8 in their outer shell, with the exception of helium and hydrogen and boron. Okay. The number of electrons in the atoms need to be the total number of bonds that they make. The number of electrons the atoms needs is the total number of bonds they can make. Okay. So 1, 2, 3, 1, 2. Okay, I'm gonna skip that because I'm not really sure what that I'm doing there. But anyway, okay, this is a finished Lewis dot structure for CH4. Okay, how did we get here? Well, carbon has 4 valence electrons. Hydrogen has 1 valence electron, but there are 4 of them, so you have 4. So what do? You add these 2 together, So 4 plus 4 equals 8. Okay. How many pairs of electrons? Because remember, when we are molecules, we are going to share. So you divide by 2, and this equals 4. So if you look here, we have 1 pair, 2, 3, 4. 4 pairs of electrons. Now, how did we get here? Hydrogen has that 1 dot. Carbon had 4, and you had 4 hydrogens. So you line it all up, and each one of these hydrogens had a dot. So there's your 2, 4, 6, 8 valence electrons, and 4 bonds. So here's how we got here, and we'll go over this in class. Count the total number of valence electrons involved, and I would be writing all these steps down. Connect the central atom, usually the first in the formula, the others with the single bonds, okay? Complete the valence shells, outer atoms, add any extra electrons to the central atom, and if the central atom has 8 valence electrons surrounding it, you're done. Now, there's some other stuff in here, okay? The central atom will have the lowest, will have the lowest valence electrons, but hydrogen and halogens can never be central atoms. Why? Because they can only make one bond, okay? Now, you are also going to have to think about sometimes you only have 2 atoms, so there's no central atom, but follow the same rules. Check and share to make sure all the atoms are happy. So there are things that we can do if they're not. We can double bond and we can triple bond. The way we show double bonds is here and a triple bond is here, okay? But if you notice, we have 1, 2, 3, 4, 5, 6, 7, 8 because these are shared, so they go here. Oops, go back. These 8 go here, and then 6 here plus 2 is 8, okay? There's 4 plus these 2 and this 2, and 4 plus these 2 and this 2. We're going to do these in class also, so don't worry, okay? We can also put the lines in there to connect the 2 dots that we're sharing, and then take the dots out, and we just have a line dot structure. So you may represent valence electrons from different atoms with the following symbol, an X or dots, okay? So I want you to try, I want you to try these, and I'm going to stop here because this video is starting to get long, but try these 2 for Lewis dots, and we'll talk about them in class.